Hello, in the previous video we got this Cisco switch as a DHCP server, so we have two different VLANs, and this layer 3 switch is able to communicate both VLANs. Now we want those VLANs to be able to access internet, but layer 3 switches, most of them are unable to use one needed protocol. If we want to go out to the internet using, for example, one NAT cloud, we have to use the NAT protocol to change the IP address from those local network addresses from the address in the other network, in the outside. And that layer 3 switch is not able to do that. So we'll need a router. And we'll use a MikroTik router. We could do that with a Cisco router, but setting up of a NAT protocol in a Cisco router is a bit more, not complex, but it's not as easy as MikroTik. So, and we know already MikroTik routers, so we'll use that. Okay, we'll use the Ether one for connecting to the NAT device, and then we'll use the Ether 2 to connect to our LAN, and I will be using the last port of the switch, the Gigabit Ethernet 3/3. Okay, it's turning on the switch and going to a console. Here we are. Remember that the user is admin, no password at the beginning. And the first thing the MikroTik router will ask is for a password. So I will use MikroTik. Okay, and we have first of all to define the IP address of the switch. In the internet side, in the Ether1 interface, we will use DHCP client. So here we'll check if there's already one DHCP client as default in Ether1. IP address print. Okay, and it is. We have a dynamic IP address because by default in the interface Ether1, that router has a DHCP client. There's also a default route. We can check with the command IP route print. We have a default route that uses the address of the NAT cloud, of the router in the NAT cloud. So from this MikroTik router, we are able to ping an internet address. Okay, it's working. Perfect. Now we have to set up an IP address here and tell that switch, that Cisco switch, has to use the MikroTik router as a gateway for going to the internet. We need that router because the Cisco layer 3 switch is unable to do NAT. So we had to use that MikroTik router. Okay, let's define the network that will connect the router MikroTik with the Cisco switch. And it will be that network. 190, 162, 192.168, okay. 0, 0, /30. I'm moving that from here. I'm trying to put things a bit more order. Okay, and that will be the network that will join the MikroTik switch, the MikroTik router with the Cisco switch. So let's put the two IP addresses. The first one will be in the router and the second one will be in the switch. In the router, IP address. I want to add an IP address. Which address? 192.168.01/30, where in the interface ether 2. Okay, IP address print, have both IP addresses. Perfect. Let's do the same in the Cisco switch. So going to a Cisco console, configure terminal. We have to go to the interface gigabit ethernet 3/3. And here we need to use an IP address, IP add, no admission. What's the problem? The problem is I cannot use an IP address in a switch interface. So first thing that I have to do in a layer-free switch when I need to use an IP in an interface is telling to the switch that that interface is not a switch port interface. With that command, I'm saying, okay, that's an interface that I don't want to be used as a switch port interface. I want to use that interface as a routing interface. So now I can IP address, I can use an IP address like the 192.168.02/30, which is 255.255.255.252. Okay, no, shut down. Let's try. Let's check if the ping is working. So do ping and want to communicate with the MikroTik router, which is the 192.168.0.1. Okay, first packet missing because ARP did not work, and then it worked. From now, all the packets are okay. And the same will happen with our router. Ping 192.168.0.2 will also respond. Perfect. So now we have connection from the Cisco layer free switch to the MikroTik. What do we need to be able to ping from the switch to the internet? The first thing we need is an default route. If we say the command do IP route, no, so do show IP route, we have that there's no gateway of last resort. So there's no default route, there's no default gateway. And we need one default gateway to be able to communicate with some different network. For example, in that MikroTik router, you've got the IP address print. That's the IP address of my MikroTik router. I could try to ping that address from here and do ping, and it won't work. Why? Because we don't know where that network is. So we need to provide some routing, some default routing. And the default route of a Cisco router is set up using the 0.0.0.0. So we'll add a default IP routes. IP routes. The road will be to the network 0.0.0.0 with the mask 0.0.0.0. That's called the default route. and any network will fit in that route. So wherever we want to go, we would use that route, and that route will use the IP address that is in the other side. So the 192.168.0.1. Okay, now if we try the same command, do show IP routes, sorry, do, we have the gateway of last resort as the IP address of the MikroTik router, and we have a static default route going to the IP of the MikroTik router. So now we could try to ping the other address in the MikroTik router, and it does work. Perfect, great. Can we go from the switch to the internet? Do. No. Why not? Because for going from that private network to the internet, we need our MikroTik router to do NAT. That's why we needed a router, because that switch was unable to do NAT. So here in our MikroTik router, we just have to add one simple NAT RAL, and that was in the IP firewall menu, and here it was in the NAT tab, and we wanted to add an action. The action was masquerade, and it had to be done in the chain of source NAT. Okay, with that NAT RAL, now we can try to check from our switch if we can ping internet, and yes, we can. Now from the switch, we've got internet access. Perfect. So if we can access from that switch to the internet, could we go from, for example, Alpine Linux 1, could we go to the internet? No. Okay, why not? I have a valid IP address from the VLAN 10. My default router is that Cisco router, and that Cisco router is able to go to the internet. What happens here? Well, we have a problem in our MikroTik router. That router knows that network 192.168.0.0/30 because has an interface plugged. That router knows any address in the internet because it has a default route that goes to the NAT cloud. But that MikroTik router does not know where the 10.10 or 10.20 networks are. So we need to define in that MikroTik router a route for going back to our VLANs. So let's try. So we go to our MikroTik router, and we have to add one route. IP routes, we want to add a route. To where? The destination address is our VLANs, and we have two VLANs, 10.10.0024 and 10.10.0024. Okay, we could add two different RALs, or just make it easier. Anything that starts from 10.0.0.0/8 will go through a gateway. Which gateway? 192 168.0.2, the address of the Cisco switch. So the packets could go from that router to the Cisco switch. And let's check now if we can ping from our Alpine Linux 1 to internet. Yes, now we can. What happens here? We are in the VLAN 10. Our default router is that switch, that layer free switch. That layer free switch is got an IP address in the VLAN 10. From that switch has got a default address that uses the MikroTik router, and then that MikroTik router uses NAT to going out to internet. When the reply goes back to the router, that router sends to the address of the VLAN 10 or VLAN 20 and has a route to go to those VLANs through the Cisco switch. So the packet goes from the MikroTik router to the switch, and then from the switch to the Alpine Linux. So now you can connect through Alpine Linux 1 with the internet, and also in the Alpine Linux 2 we can connect to the internet. Well, then we've set up a basic setup with two different VLANs in that layer free switch, and we've set up a default route in that switch, a default route in the MikroTik router, and also we've added another route to the MikroTik router to reach both VLANs. And also that MikroTik router is doing NAT for translating the private IP addresses in the VLANs to the internet. So, done.